Hi, thank you all for coming. It's really great to see so many faces here. This is actually our first event in London, so this is a pretty good turnout. So thank you so much. So welcome to our Blockchain for e-Governance meetup. We are Binary District, and we are an educational platform and community that specializes in disruptive technologies, and we are all about supporting and facilitating meaningful interactions between those with extensive knowledge of disruptive technologies and those looking to learn and upskill. So at the moment, technology is advancing at such a crazy rate, and because of that, it's very much prone to myths and misconceptions. And for us, it's so important that we interact and have meaningful and productive discussions with those researchers and developers who are actually forwarding the industry, as opposed to kind of relying on bigwig corporations to inform us as to what's going on with new technologies. So that's what we're focused on and what we like to bring to the public. So what we do is we have various courses on disruptive tech, including blockchain, VR, big data, cybersecurity, and we also have a lot of really cool events, conferences, hackathons, and meetups. So most of our events have been in Moscow, Amsterdam, and we recently had one in Berlin. And we're really excited to be venturing into European markets and coming to different tech cities in Europe and bringing our courses and events here. So this is a really good move for us, and we're really happy to have you all and to see that there is a lot of people interested in disruptive tech and blockchain in particular. Our courses aren't just about educating people about technology and kind of the theoretical side of it all, but also giving people practical skills. So helping businesses implement these technologies as well. So these are really, really useful, and we think that we are genuinely helping develop the industry and move it forward. So these are our upcoming events. We have a really, really exciting open lecture with Peter Todd, a blockchain developer, which we held in Amsterdam at Primal Base co-working space. In Moscow, we have a lecture with Zuko Wilcox from Zcash. We have another event at this venue, actually, with Philip Yanukovych for blockchains for payment processing, which will be in February. And probably the one that we're most excited about is the third installation of our Genesis conference series. So we've already had two in Moscow. Our most recent one was in September, and we had some really, really great speakers, including Patrick as well. And it was great. He will attest to that. It was amazing. He's nodding his head. So we're bringing that to London, and we have a short video from our Moscow conference, and to get an idea of what it was like and how it all went down. So enjoy. Thank you. So like as you can see, like it was actually that cool and that fun, and I can't wait to see who comes to the event in London and to have the same experience and see what the London community is like as well. Here are some of our speakers. We have Eli Ben-Sasson, Jack Gavigan, Peter Todd, Tim Ruffin, Ido Bentov, and there are more speakers to be announced. So please do go onto our website and keep an eye out for additional speakers who are coming and upcoming events. And I hope to see you all there. The actual conference will be split into kind of 4 streams: research and development, regulation, economics, and applications. Because for us, we feel like these are kind of the 4 most pertinent areas of blockchain that really do need to be discussed. So it's not just about kind of hype and exaggerated promises, but like real discussion on how this technology can be like applied in real life and viable applications. And finally, we're really proud that I think maybe like 3-4 months ago, we launched a binary registered journal. So it's a tech journal with lots of really interesting articles about disruptive and new technologies. They're very analytical. We have features from some really, really interesting experts in tech and various industries, and we're all about debunking myths and really just facilitating real conversations on new technologies and real applications of these technologies. So please do be sure to read our articles and check us out on Facebook and Instagram and Twitter and comment and let us know what you think. And yeah. So I'm going to pass the mic over to someone who is significantly more experienced with public speaking than I am. So Martin will be moderating and will introduce our amazing speakers. So thank you so much for listening to me.
Hello, hello, hello. There we go. Okay, hi, my name's Martin Bryant. I am, well, until about 2 weeks ago, I would have said I'm a tech journalist. I've very, very recently, just the start of this year, become a consultant working with tech companies and publishers around content strategy and storytelling and all of that, and doing workshops with people about emerging tech and all that kind of stuff. So an exciting new start to the year for me, and at an exciting time for technology. You're all here because you're all interested in blockchain, and blockchain is for me, I think, one of the, probably the biggest move forward in technology in terms of public interest since social media 10 years ago. Yes, there's been lots of other tech advancements since then, but I really think that if you look at the broad interest, people actually wanting to find out about blockchain, it's kind of on a par with social media 10 years ago, where it was just about to go mainstream and people were really excited about the advancements and where it could take us. I was one of the people who started an event in Manchester 10 years ago about social media, and we thought maybe 30 people would turn up, and 85 turned up, and then it turned out to be this big thing, and people were really into it. And now you'd never do an event about social media. It'd be like doing an oxygen event or a water event, wouldn't it? It'd be pointless. But maybe we'll be at that stage in a few years with blockchain. But with all the hype and excitement comes a load of old guff. People talking about how they're going to change the world of petting zoos or change the world of space travel or something with blockchain. But with blockchain is a bit of a startup pitching cliche these days. Just ask any VC or journalist. They probably get pitched something to do with blockchain or crypto every single day. And at the same time, you've got somebody I went to school with who's now a tree surgeon, who I've spoken to on Facebook precisely once when he friended me about 10 years ago, messaged me the other day saying, should I buy into Bitcoin? So yeah, even the tree surgeons are getting into it now. But set aside all the novelty, and among the areas that are genuinely interesting when it comes to blockchain is e-governance. And as the description for this very event online put it, can blockchain bring efficiency, convenience, and simplicity to government services? Well, we're going to find out tonight. Just a few of the things that are going on around the world in this field already. Dubai made headlines recently with its aspirations to be the first blockchain-powered government. It wants a paperless digital layer for all city transactions, for things like visa applications, bill payments, and license renewals. It wants to encourage businesses to use blockchain. It's going to have a global trust network for things like passports and visa approvals and all that kind of thing. It wants 100% of Dubai government transactions to be blockchain powered by 2020, and it wants to share its platform with the world so other countries and other cities can do similar. Elsewhere, Ghana has a blockchain-powered land registry. Estonia has a blockchain-powered technology that secures government data and is also being used around the world. And governments around the world have said, yeah, we want to use blockchain too. So exciting times. And inevitably, companies like IBM, the big consultancy firms, really want a piece of this pie too. As Marie Week, the general manager at IBM Blockchain, yes, IBM has its own blockchain division, wrote in a guest post on CoinDesk last month, citizens increasingly expect the same ease, efficiency, and innovation from public services that they currently enjoy in the private sector. Conflicting data formats, long-standing interoperability challenges, and a need to balance the benefits of openness against the need to protect privacy have made it difficult for governments to unleash the full potential of their data until now. Blockchain provides an immutable, transparent record of the truth and is changing how organizations carry out trusted transactions. Honourable stuff. That's almost utopian, and yet you've probably seen recently a number of writers have been publishing blog posts or books with a bit of a blockchain backlash, maybe a blocklash you could call it. People saying things like it's not really proven itself. Blockchain's been around for 10 years, and we've not really seen anything come out of it that's been of much use. But I think we're getting to the point now where that's starting to change, and we're at a bit of a wild frontier when it comes to government services, which sounds far more exciting than government services normally sound. It's exciting but challenging times ahead, and not everyone will want to come along for the ride. We live in an age where the United States is described by some people as a nascent kleptocracy, where a rich elite structures government and legislation in a way to take more and more from the rest of society to line their own pockets. If you've got dodgy backhanders to hide, or don't want people to think that, or you want to make people believe that election fraud is rife when it's not, then maybe you're not so as enthusiastic about blockchain as an open government enthusiast might be. So will governments that embrace the openness of blockchain technology surge ahead of those operating more closed models? And what about a country like China, which is traditionally more closed? It's embracing Bitcoin and indeed blockchain. But where exactly will it go? Will it go in a different direction to blockchain-based systems in other parts of the world? And will the technology stick for every government, or will some of them retreat back to more closed models eventually? Will humdrum reality bring some of these blockchain dreams crashing down? Open source advocates like to talk about how Munich shifted away from Microsoft to Linux-based government computer systems, and showed. And this was really exciting for open source software advocates. And now Munich's starting to move back to Microsoft because some people still like that familiarity of a more closed, centralized system with a brand name behind it. I was reading an article just yesterday by Sam Lessin on the website The Information about centralization versus decentralization, or traditional software models versus blockchain, you could say. And in it, he eventually concludes that in about 10 to 15 years, most large companies will have a hybrid strategy, decentralizing the most critical components of what they do and centralizing where they need efficiency more than trust. But the path to that endpoint is going to be where the value is created and lost. And likely just as many mistakes will be made over decentralizing as will be made by staying overly central for too long. In other words, we're not on a simple path to a gloriously decentralized future. It's going to be challenging, but the potential for exciting new approaches to government is undeniable. And our speakers tonight are going to dive into this in a lot more detail. Through the night, please do tweet about what we're going on about here, and tweet your comments and your thoughts about it with the hashtag binary district. And so we're going to hear from our two speakers, and then you'll have a chance to ask questions in a bit of a Q&A at the end. So make a mental note about your questions, and we'll come back to those later. So first up, we're going to hear from Patrick McCrory, who is a research associate at University College London, and he's going to talk about the Open Vote Network. Please welcome Patrick.
Hi, guys. Ahead of my slides. You've already seen the end story. I'm only joking. If I can get this. Okay. Yeah, so I should introduce myself. My name is Patrick McCrory, and I'm a postdoc at UCL. I'm the UK's first PhD graduate in cryptocurrencies, so I started doing Bitcoin research back in early 2013. And this is sort of like a project I did near the end of my PhD. I remember that near the end of my PhD, I thought, okay, I want to build something for the community that they can sort of take away and let it evolve on its own. And it sort of happened with this project. So, and because it's about e-governance, I don't know about the social aspects that much because I'm a technologist. So I'm going to describe a voting platform that could be used for some type of e-governance in the future. And the main point is to sort of remove the hype around blockchain to show what does blockchain solve in an e-voting context. So now I'm going to present a smart contract for boardroom voting with maximum voter privacy. And when we talk about e-voting, we tend, in the academic world anyway, and I guess for industry as well, we tend to think of end-to-end verifiable systems. And what do I mean by that? So if I'm a voter and I'm going to cast my vote in an election, I should be able to go to a ballot box, and then when I cast my vote, I should have confidence that my vote was cast as intended. Is this on, by the way? Yeah, okay, I just wanted to make sure. Okay, so once I cast my vote in the voting machine, I should be guaranteed that I voted for Obama and I didn't go for Trump. Then when I leave the ballot box, and I should be able to look at this public bulletin board, and I should have confidence that my vote was recorded, recorded as cast. And then when I leave, and then after the election's over, I should have confidence that my vote was part of the tally. And even with all these requirements, we should be able to do this in such a way where I can't sell my vote, which is why e-voting is such a difficult problem. Now, to achieve an end-to-end verifiable system, we tend to assume an existence of a public bulletin board that provides a consistent view to all voters. And unfortunately, the best thing we have in practice today is a single web server that is hosted by the election authority, and we can only detect if they try to cheat us by coordinating amongst ourselves, and that's really difficult to do. So when a lot of people think about e-voting and e-governance and then the blockchain, this is sort of what they're looking at. They're saying, okay, can the blockchain provide us this consistent view to every single voter in the election? And now we need to think, okay, and I'm going to argue it can potentially provide this consistency property. Because if you think about systems like Bitcoin and Ethereum, the whole point is that when you join the Bitcoin network, you download every single transaction that's ever occurred on the network. And then you reach the same view as everybody else. So if you send me a Bitcoin, I'm guaranteed that, one, you own that Bitcoin and you're authorized to spend it. And I should also get a guarantee that once I get the Bitcoin, it has not been double spent. And that's simply because of the public verifiability and the consistency property of these blockchains. And of course, but I think this would have been, maybe 2 years ago I did this Google search when I was really thinking about blockchain and e-voting. And it's a really overhyped area. Obviously, lots of people are thinking about how to do this. And so the next natural question is, can we use Bitcoin for e-voting? Is Bitcoin a usable platform for that? And normally I'd go in and talk about Bitcoin and describe roughly how it works. Maybe we should have a raise of hands. How many people in this room are familiar with Bitcoin? Okay, and you have a rough idea how it works. Okay, so there's a rough idea here. So the long story short, I guess, I would say that Bitcoin is not suitable for e-voting because the issue with Bitcoin is that in every Bitcoin transaction, you can only store 80 bytes of data. So it's more of like a time-stamping service. I can say that the voting data existed at this point in time, But the other issue is that the Bitcoin network cannot ensure that the voting protocol is run correctly. It's only useful for storing data. So the next question is, can we use Ethereum for this? And to give a bit of background, when I made these slides, Ethereum was worth $20 billion. I really don't know what it's worth anymore. I think it's worth maybe, how much? Okay, it's worth 5 times when I made this slide then, yes, it was worth $100,000. Now, the whole point of Ethereum was that it was sold as this idea as a global computer that can run bounded but expressive programs. And in reality, it's a bit like a computer from the 1970s. I don't know if anyone in the room had a CryptoKitty or has a CryptoKitty. Do you want to raise your hand if you have a CryptoKitty? Yes, one guy in the room. You have a CryptoKitty. You've got 2 CryptoKitties. Oh, you breeded them. Okay, but you understand then, when CryptoKitties came out, that's when we first seen the first strain of Ethereum. I mean, the transaction fees went up because that global computer was struggling to process all these transactions. But it's actually quite weird because you have to auction your kitty off, I think. And that's like a lot of the computation part. But anyway, so we know that this is like a computer from the 1970s. And of course, this talk is obviously about voting over the blockchain. So there's actually a bit of a story behind. Don't worry about the code. That's just there to make it look pretty. 2 years ago, I was in Barbados, and I was in like a hot tub drinking a pina colada. And I got talking to some of the people from the Ethereum Foundation. And back then, I didn't really know about Ethereum. I knew that like the Kickstarter project that was being built, there was this thing called smart contracts. And they were like selling me this idea of what smart contracts could do in the future. So when I got back to England, and at the time I was living in Newcastle upon Tyne, I remember going on the online compiler, and the example program I found was an e-voting program. And this is the exact program I found. And I can briefly explain it. So the idea is that in the smart contract, there's a list of proposals. And if you want to vote for a proposal, you call the vote function. Then you say, yes, I want to vote yes for that proposal. And then the proposal with the most yes votes wins the election. Now, the issue here is that the contract has no real voter privacy because all the votes are public. I mean, it literally counts the number of yes votes, and that's illegal in a lot of elections. And the other issue is that in terms of voter privacy, like linking to a real-world identity, it just relies on the fact that you can't link my Ethereum account to my real-world identity. And we know that that's a really difficult problem to prevent. There's lots of research in that area. So after I'd seen that example program, I really wanted to get my hands dirty with Ethereum and see what we could do. So then I wanted to think, okay, can we build a smart contract that can guarantee the voters' privacy? And I should also mention, in these blockchain worlds, in these smart contract worlds, you can imagine a smart contract as a bit like a trusted third party. This trusted third party will do anything you want. It'll run the code, and it will never cheat you. But it can't keep any secrets. So we're in a world where we can't keep any secrets. It is still possible to guarantee voter privacy. And in cryptography, there's 2 ways to do this, typically. One idea is called a blind signature. And the idea there is that all the voters, they have a voting token, they blind it, and they give it to an authority. Then once the authority has a list of voting tokens that are all blinded, the voters come back, and then they get the voting token that's signed by the election administrator, or the authority. They unblind it, then that voting token is now their voting key, then they can use that to cast their vote. And the idea there is that you're obfuscating the link between the voter's identity and their ballot. The second approach is encryption. The idea is that I can encrypt my vote, send it to the network. After the election administrator can decrypt all the votes, and then they can reveal the tally. And they do it in such a way where they can't link it to my real-world identity. But the issue here in both approaches is that you rely on the participation of a third party to run the election. And I wanted to do something a little bit differently. I sort of wanted to follow the example of cryptocurrencies. Can we remove the need for any trusted authority in an election and still guarantee voter privacy? So when I was looking through the academic research, I discovered this thing called a self-tallying election. And they have 3 different properties. The first property is perfect ballot secrecy. So as a voter, my privacy can only be breached by a full collusion of all other voters. It's also self-tallying. So once the final vote has been cast in the election, anybody can compute the tally. And third is dispute-free. Given the entire election transcript, we can verify that the voting protocol was run correctly. And this was done by, I can't actually pronounce the names, Cass and Young. So this idea is from 2002. Now the issue with a self-tallying election is that it's not end-to-end verifiable, the thing I mentioned at the very start. Because as part of an end-to-end verifiable system, you can't actually trust the voting machine. And one way to get around that for an end-to-end verifiable system is that when you go to the ballot box and you cast your vote, some voters should be expected to challenge the machine. So I cast my vote, the machine gives me a printout, and then I spoil my ballot. Then if I can detect the machine cheated me, then I can give that to the authority and we can see that, the election's a bit corrupt. But in our case, because it's completely decentralized, there's no trusted authority, we have to assume the voting machine is trusted. Because this is this is a user's personal device. We don't have anyone to give devices out for the election. And that's a reasonable assumption because if you can steal if you can break my privacy, you can probably steal my coins as well. So users should be somewhat reliable for keeping that secure. Yes, but self-timing elections have had a short-lived history. Because one, they require an authenticated broadcast channel. Because it's decentralized, it's a bit like being in a room with 10 different people. I need to be sure that Patrick is casting that vote. So I have to be able to authenticate all messages from Patrick. And it's also beneficial to have a public bulletin board to aid coordination. So the idea is that if there's 10 people in the election, they all cast their vote and it's stored in a central place where everybody can see the voting data. They've also not been practical because, one, there's an abortive issue. If a single voter does not cast their vote, then it's impossible to compute the tally. And there's also an adaptive issue where the final voter can compute the tally before everybody else because of its decentralized nature. But thankfully, if we use a blockchain like Ethereum, we can somewhat get around those issues. So what I did was that I implemented a voting protocol as a smart contract. And what we discovered was that Ethereum's really well suited for building cryptographic protocols like this. And you can also have this sort of incentive to participate. So in terms of an e-governance scenario, imagine there's a bunch of banks, and they all want to change the rules of the system. What they could do is that they could run this election amongst each other, and if one bank doesn't vote, then they could be forced to lose their deposit. So that way, in a small boardroom setting, people can be forced to actually vote in the election to avoid that abortive issue. And there's 3 different protocols to do this. The protocol I chose was called the Open Vote Network. And my disclaimer is that when I was doing my PhD, this was the protocol of my advisor, but that's not why we chose it. In terms of the 3 protocols that exist, it's the most efficient. It only has 2 rounds of communication and very little cryptography involved. And I'll not go into the detail there. But as you're going to see, even this very simple cryptographic protocol is still really expensive to run on a network like Ethereum or a public blockchain. So the Open Vote Network over Ethereum, how does it work? Okay, first, for our proof of concept, we do have an election administrator, but his role is to do the following. 1, his role is to authenticate the voters. So ID, he sets up the contract, and then he stores a list of Ethereum accounts that are eligible to vote in the election. So his job is to link, if I want to participate in this election, he checks my ID, and then he says to the contract, Patrick's allowed to vote in this election. And then he sets up the voting question, and he triggers the setup stage. Okay, yeah, finally got the registration. Okay, so now in the sign-up stage, if you're eligible to vote in this election, you can go on the website, you can look at the voting question, and if you want to cast your vote, you can then sign up for the election. And the way you do this is that you have to register something called a voting key. And a voting key is simply a public-private key pair. So I don't want to go into the cryptography too much, but as most people in this room are aware, you have like an Ethereum account and a Bitcoin address. All that is a public key that you can publicly give to everybody. And for every public key, there's a corresponding private key. And that private key is what you keep secret. So when you want to authorize a transaction, you get your private key, you compute a digital signature on top of the transaction, and you broadcast it to the network. Then everybody can see that your Bitcoin address created this digital signature that authorized the transaction. And that's basically the idea behind a public-private key. Okay? So in this case, we have a voting key, which is just a public key. And what I do to the contract is that I send a transaction, and I tell the contract, this is my voting key. And I also provide something called a zero-knowledge proof, where I can convince the contract that I am the owner of this voting key. And nobody else but me can convince the contract of that. And I also leave a small deposit to show that I'm committed to this election. Okay, and every single voter will do this. So every single voter will create this transaction and send it to Ethereum. Ethereum can verify that I own the voting key, and then it will store it alongside my deposit. Oh, I made too many slides. Okay, so now we've finished the sign-up stage. Now you can imagine we have 40 voters, and they've all registered for the election. The next step is that we need to poke Ethereum and tell it to transition to the voting stage to allow everybody to cast their vote. Oh no, too far. Okay, that's fine. And then during this transition, so you imagine the election administrator. He looks at the contract and he can see 40 people have signed up. He creates a transaction, he sends it to Ethereum, and then Ethereum will move from the sign up to the voting stage. And during this transition, Ethereum will compute a second key for every single voter. And we call this the reconstructed key. Now I have this really ugly formula on screen that nobody's going to understand. So the idea is that what Ethereum does is that it computes a second key for every single voter. And the way the key is computed is the following. If I'm voter 3, we get the voting key for voter 1 and 2, and we add them together. And then we get the voting key for 4 and 5, and we add those together. And there's only 5 people in this election. Then we divide the 2 keys, then we get my reconstructed key. And we do that for every single voter. So then once we're at the voting stage, every voter has a voting key and a reconstructed key. And now everybody can cast their vote. Oh, no, too far. Scary symbols. Okay, fine. Okay, oh no. Sorry, guys. This is why we don't trust technology. The monitor's rigged, like the election. Okay, anyway, so now what we need to do is that we need to send an encrypted vote to Ethereum. And what we're going to do is we're going to send an encrypted vote, which is basically yes or no. So if you imagine the voting question is, should Satoshi Nakamoto reveal his real-world identity? You could sign up for the election, and then you could cast yes or no. And the way and don't worry about the symbols too much, but effectively using my voting key and my reconstructed key, I can create an encryption of yes or no. And once I've created that encryption, I can then create another zero-knowledge proof, the special cryptography there, where I can prove to anyone that my encrypted vote is either yes or no. Because the problem is that if my encrypted vote is, like, for example, so if you imagine the encrypted vote is, the represent no is 0, the represent yes is 1. If I could create an encrypted vote where I encrypted the number 5, then I could vote 5 times. So it's really important that I can prove to people that my encrypted vote is either 0 or 1, i.e. is either yes or no. So I do that. I do an LGML encryption, and don't worry about that too much. And now what I do to the contract is that I send my encrypted vote, and I prove to the voting contract that my vote is yes or no. And every single voter will do that. The contract will verify that the encryption is correct, and then it'll send me back my deposit. Oh man, it's actually hurt my fingers doing this. Can somebody move the slides on? Oh yeah, thank you. Is it me? Oh, am I person? I did that though. Let's see if that works from now on. Okay, so basically, after we've sent all the encrypted votes to the contract, we now move on to the tally stage. So effectively what we do is we get all the encrypted votes, and we simply add them together. And once you add all the encrypted votes together... How did you do that? That was magic. Okay, so effectively what we do is that we have all these encrypted votes, we add them together, and then we can leak the tally. So we can say, okay, given 40 votes, 5 people voted yes. Now the really cool thing is that we demoed this on Ethereum, and let's move on to the next one, because that's the more recent cost. Okay, so to run this type of election on Ethereum using cryptography, the cost of vote costs around 60 cents. So actually running this on Ethereum it's a reasonable cost for a small election that's maybe 40 people, but for a national scale election that's fairly expensive. And it actually requires it actually can congest the network. So as I said, Ethereum is sort of like a computer from the 1970s. So every vote, so if you consider, does everyone know how Ethereum works with like blocks, etc.? Put up your hand if you know how that works. Okay, so some people do. Okay, so the idea that in Ethereum, there's a new block roughly every 12, 15 seconds. And inside a block, that is where transactions get confirmed. Now, these blocks have a certain capacity. They can only fit so much stuff in. It's a bit like a bin packing problem. Now, in our system, an Ethereum block can only store maybe around 3 or 4 votes. So given this one application, if there's 4 votes if there's 4 votes every 15 seconds, we actually take up the entire capacity of the network. So this is demonstrates it's just a simple application. Ethereum can't yet support it, but it is getting a little better. Okay, so now the next question is, can an e-voting protocol, I mean, this is a fairly straightforward one, but can we have an Ethereum-like blockchain scale for a national scale election? Come on. You want to work your magic again? Oh, there we go. Okay. So we imagine Ethereum can handle 10 transactions per second. Let's just say it can handle that. And we want to have, that means it can roughly handle around just under 1 million transactions per day. If we have an election of 44 million people, which was the UK election a few years ago, you're probably going to be waiting like 44 days, so just over a month. So as we can see, if we want to run a voting protocol like this on Ethereum, it's just not realistic for a national scale election. But what it is really useful for, and it was actually part of the interview questions for the Brazil one, what these blockchains are really good for, or as a time-stamping service. So I think it was Brazil, where they wanted to use the Ethereum blockchain for their national scale election. And effectively all they were doing was that, given all the votes, I store a commitment on the Ethereum blockchain. So in the future, anybody can look back at that period of time, and they can verify that the voting data has not changed. So it can add some integrity that way. But the takeaway for this is that public blockchains like Bitcoin or Ethereum are not yet ready for national scale use. Sorry, 10 minutes? Oh, I'm nearly done. It's fine. Yeah. Okay. So, the next question is that can we use a permission blockchain? Maybe something like Hyperledger or Corium, etc., or even maybe RSK, I guess. The benefit of these blockchains is that if you imagine in the Bitcoin world, if you want to maintain the blockchain, you have to do some type of proof of work. So you're financially motivated, you buy all this hardware, you compete in a lottery system, and if you win the lottery, you create a block and you get rewarded. Now, in this case, in a permission blockchain, it's a bit like a company. You're appointed to maintain the blockchain, and you're appointed to do that because someone trusts you to do that. Now, the issue is that if you appoint people to maintain a database or a blockchain, you might have some type of censorship issue. But the benefit of a blockchain is that because everything's public knowledge, there's no secrets. That's why we have to use cryptography. But if there is any type of censorship of transactions not getting into the blockchain, that can be detected. So the benefit of a permission blockchain is that we can detect censorship. So actually for e-voting, there's some arguments where this could really be useful. And it can also scale quite well so they can handle millions of encrypted votes. Because there's effectively 5 people here appointed to run the blockchain. It's very centralized, and with centralization, you can scale quite well. That's why Facebook, etc. That's why they can scale quite well, because they're all highly centralized. So the takeaway here is that the benefit of a permission blockchain for e-voting is, 1, everybody can verify the election transcript. A blockchain is really useful for replicating data across the network. Because, I mean, if you consider Bitcoin, the whole premise of Bitcoin is that I can store the entire transaction history of my computer. And I can independently verify myself that nobody's cheating me. That is the exact same case for permission blockchain for e-voting. I can store all the voting data myself. I can verify the election myself. And I don't have to trust anyone to do that. That is sort of the goal of the previous small-scale election. But what does a blockchain not do? Because this is sort of like the takeaway of this sort of research. We look at blockchain, and we look at e-voting protocols, and then we can finally understand, okay, what does a blockchain give us for e-voting and subsequently, e-governance, because all e-governance relies on some type of voting protocol. It does not solve voter coercion. Everything's public knowledge. So if I want to sell my vote, if I can prove to somebody so if I store an encrypted vote in the network, the person coercing me can see my encrypted vote. And if I can prove to the person coercing me how I voted, then, I get the bribe, he gets his vote, etc., etc. And that's illegal for a lot of elections. Blockchains do not help with that at all. It's the voting protocol that supports that. And the only way to achieve that is that when you cast your vote, you need to have a private moment to cast your vote. So you go into a ballot box, you cast your vote, and then you walk away. And this is where e-voting gets really tricky. Because when I leave the ballot box, I should have enough evidence to convince myself that my vote was recorded in the election. But I should not have enough evidence to prove to someone else that that's my vote. I should only be able to independently verify myself, but not convince others. And that's why e-voting is really, really tricky to get right. Blockchain does not solve voter privacy because everything's public knowledge. So in the boardroom example, we had to use some very, very cute, it's been described as cute once, very cute cryptography to achieve some type of voter privacy. So you can see that Paddy has cast his vote, but you can't open my vote because it's encrypted. And it does not solve ballot stuffing. So as I mentioned in our system, there's still this election administrator who has to authenticate voters and register and add their identity to the network. They should make me eligible so I can cast my vote. Blockchain does not get rid of that. That relies on how you authenticate your vote, and even many voting protocols don't try to solve that problem because it's a human problem, generally. Oh no. Okay, so my conclusion is that for e-voting, and subsequently, if we go on the e-governance and how we can do e-governance using the blockchain and e-voting protocols, is an iterative progression. Blockchain does solve that problem of providing a consistent view to all voters. It can provide us this ideal public ledger, ideal bulletin board that we have not had for over 30 years. And that's based on replication. We can replicate the data out, and everybody can be guaranteed they all have the same data. But that only solves one small problem in secure e-voting. The project is on GitHub, and there's a beautiful YouTube video where I talk you through the system. My accent probably makes it very hard to understand, but it's there.
Hiya, today I'm going to show you how to install the OpenVote network as a smart contract on Ethereum. Now this is a decentralized and self-telling election, and what I mean by that is that these protocols have three different properties. The first is that it's dispute-free, so given the full execution transcript of this protocol, anybody can verify that the protocol was run correctly. Second, it provides maximum voter privacy, so the voter's privacy can only be breached by a full collusion of all other voters. And third is self-tallying, so nobody is responsible for computing the tally. Instead, anyone, including any observer, can simply add the encrypted votes together, and this will reveal the tally of the election. To begin, we have the Ethereum wallet, and we connect it to a private test network. What we'll do is that we'll copy and paste the code for the anonymous voting into this wallet, and we'll deploy the contract on our private network. But what we also need to do is we need to fill two parameters. The first is that we need an Ethereum account to represent a charity. So if a voter registers for the election and doesn't cast their vote, they lose their deposit and we send it off to charity. The second parameter is called the gap. And the idea is that the smart contract can self-enforce the minimum time for each round. So for example, registration should remain open for 2 hours, and there should be 3 hours for the voting phase. And that is what the gap represents. Now what we do is that we deploy the contract, and this requires, in my example, 4.7 million gas. And next, we now need to deploy what we call the local crypto library. And this library has all the cryptography to verify the zero knowledge proofs. So again, we copy and paste that code, and then we create the contract, and we send that off to the network. And in this example, it requires 4.3 million gas to create our contract. We send the transaction off, and of course now the contract's there. So next what we need to do is we have 3 web pages, one for the voter, one for the admin, and one that is a live feed that allows observers to watch the election in progress. We need to update each HTML file to include the contract address for the anonymous voting contract and for the local crypto contract. So as you can see here, I'm simply updating the values using copy and paste. Now what we do is we open up the admin page and 3 voter pages. So the election administrator is responsible for creating the election and authenticating the voters. And of course the voting page is for voters to log in and cast their vote. So here the election administrator logs in. He'll update the list of eligible voters. Now I have this pre-defined in the website to make my job a little bit easier, all I was testing. But I mean, you have the Ethereum accounts, you hit update eligibility list. This creates a transaction, broadcasts it to the network, and now these voters are eligible to vote. Now we update a list of deadlines to ensure the election runs in a timely manner. For our example, we separate each deadline by 1 minute, but in real life that would be hours or days. Finally, the election administrator sets the question. He specifies what deposit the voter must leave in the contract, so this is 1 Ether, and whether the additional commitment round should be enabled or disabled. It is worth mentioning that for our example, we have enabled the commitment round, and I'll explain how that works very shortly. Next, our 3 voters will log in and register for the election. What they do is that they upload a file called voting codes, and this can be computed using the Java program that I have made available in the GitHub. These voting codes are simply random numbers that are used as part of the zero knowledge proof. And we decided to do it this way because if the browser crashes, then those numbers will exist. I mean, they could just reopen the browser, log in, and then they do not have to worry about recomputing random numbers. And what happens here is that when you register for the election, the website will create an Ethereum, it'll notify Gith to create a transaction and send that to the contract. So it will register a unique voting key for the voter, and it will prove in zero knowledge that we know the secret key to that voting key. Once the smart contract verifies that that zero knowledge proof is correct, it will then accept a 1 Ether deposit from the voter. Now at this stage, all 3 voters have now registered for the election. So the election administrator, he can finish the registration phase and allow each voter to move on to the commitment phase. What happens here is that each voter can now decide to vote yes or no for the question. And what this will do is that it will create an encrypted vote, it will hash the vote, and then the hash is stored in the smart contract. So we're using a commit and reveal paradigm. So all voters commit to the vote, and then once everybody's committed to their vote, they then reveal the encrypted vote to the network. So the encrypted vote sent to the smart contract alongside a 1 out of 2 zero knowledge proof, and then once the smart contract verifies the zero knowledge proof, this guarantees that the vote is either 0 or 1, which represents yes or no. Now the commitment round is not necessary. I've only enabled it for this example to explain how it works. Ideally you should just do register and vote, because then there's only 2 rounds of interaction. And then of course finally, once all the votes have been cast, anybody can compute the tally at this stage. Now I request the election administrator to hit the tally button, just for 1, he'll pay the transaction fee for that, and 2, now the smart contract has computed the tally, and now if anyone goes on the live feed page, this website will look up the current state of the voting contract, and then the tally is recorded in the contract, so it's fairly straightforward to display it on the website. And as we can see here is that voters have committed to their vote, they've registered for the election, and they've cast their vote, and now we know the final tally.
My takeaway is that this is the first of many cryptographic protocols that come. Because as I mentioned, these blockchains are like trusted third parties, but they can't keep any secrets. So if we want to do anything interesting where you need some type of secret, you have to use some type of cryptography. And in this case, we use cryptography for e-voting, but you also use cryptography for auctions, etc., and poker. There's a really cool poker paper that I highly recommend. And that's the end of my talk, I think. Yes.
Thanks a lot, Paddy. If anyone is working on PowerPoint but on the blockchain, then I think we want to hear from you after that. So thank you very much, Paddy. That's very fascinating stuff. Right then, next up, first of all, let me remind you, do please tweet about what's going on tonight. There's been a few tweets out there, but we want more. Tell the world what's going on here. Hashtag binary district. But next up, we are going to hear from Daniel Gasteiger, who is going to be talking about blockchain as an enabler for e-government and digital societies. So please welcome Daniel.
Thank you. Thank you very much. Now let me fight with the thing. Hopefully. Yeah, good. Hello, my name is Daniel Gasteiger. I'm from Zurich in Switzerland. I'm here to talk a little bit about how blockchain can enable governments and digital societies. I'm going to do a totally different talk. I'm totally not academic. I'm totally very practical. I'm actually a banker by profession, so I was working in financial services for 20 years, and I started to get involved with Bitcoin and blockchain in 2014 when I decided, after reading a few books, after coming across Ethereum in Switzerland, to give up my job in financial services and start my own business. And my first business was called Nexus Squared, or is called Nexus Squared, which is a consultancy company in Switzerland that helps startups, but also corporates to get in on top of this topic of blockchain. And through that, I got to visit a couple of countries in the eastern side of Europe, including Estonia. And in Estonia, and I come to that now in a second, the story of Estonia and the e-Estonia basically then inspired me to found this company ProCivis, which is what I'm representing here tonight. And I'm going to talk a little bit about what has happened to me over the last 18 months when it comes to this topic of how blockchain can actually empower and enable digital societies. So let's start with the story of Estonia. As I said, I was there for the first time in 2016. And coming from Switzerland, which is basically a pretty modern country as well, as a rather rich country, going there is really opening my eyes in the sense of seeing what a small country like Switzerland, but not quite so modern and so progressed when it comes to the economy, can actually do with little means and become a total digital society. And so let's quickly look at a video to illustrate this.
Imagine starting a new country completely from scratch, freed from any pre-existing economic system, tax laws, or formal government. A bankrupt country with its future and direction completely in the hands of its people. That's the story of Estonia. It was 1991, the Soviet Union had collapsed, and Estonia had just regained its independence. But with few resources and a small population, the country had to find a way forward. With the internet beginning to boom, leaders decided to invest in and build an e-society. The first project was Tiger Leap, which put computers and the internet in every school and got Estonians online fast. By the late 90s, all Estonian schools were online. In 2000, Estonia became the first country in the world to declare internet access as a basic human right. And today, Estonians are connected online through a mobile ID.
Using that ID card, we can do everything. We can vote online in elections. We can declare our taxes. We can register businesses. We can do e-school, e-police, e-cabinet, you name it. And everybody is very used to that.
All of this personal data is protected by technology called blockchain, a decentralized network with countless channels that make it exceedingly difficult to hack. And as a backup, Estonia will create the world's first data embassy in Luxembourg, a storage facility to house an entire backup of Estonia's data capable of rebooting the country in case of a cyber attack. The result is a country that runs like a tech startup. Estonia teaches first graders how to code. It has the world's fastest broadband and holds the records for most startups per person. Creating the future is Estonia's driving project, and increasingly its core business too. With the introduction of e-residence, Estonia is hoping to invite entrepreneurs to invest in the country.
So each person globally can apply and get this e-residency card the same way Estonians have been using that for 17 years. Using that card, e-residents establish company, establish bank account, open different PayPal and other solutions, and then you can remotely manage and administrate the company fully online.
So far, just 18,000 people have signed up, but some believe that with 10 million e-residents paying $100 a month each, Estonia would not even need to tax its citizens. It's certainly an ambitious goal.
So this is the story of Estonia, the most digital country in the world by now. And after having been there for the first time, I came home to Switzerland and I started looking around what's actually happening in my country when it comes to digital identity, e-voting and all these good stuff that they have in Estonia for a while already. And I realized we are actually number 29 or number 30 in the European league tables when it comes to the digital society or the digital government. So really at the very bottom when it comes to that. So this inspired me to do something about it, and I started connecting a few dots, including my network of blockchain. I started reading heavily about these trends. And basically, it all starts with a national digital identity solution. That's the enabler. That's how it actually this whole digital society strategy starts working. So you need a digital identity that ideally comes from the government, and then ultimately the government makes this a thing to use every day, and that's how it actually starts in Estonia. As we heard, Kaspar from the video is also by now a friend of mine and an advisor to my company. This is his identity and his name. This name is basically a 12-digit number, and that's basically identifying him across all systems, across public and across private sector applications. That is then basically hooked up to what they call now a blockchain-inspired architecture. So these databases that you see here, they're all directly linked with one and each other through this what they call X road, and in the bottom left and bottom right you see the digital identity server that ultimately connects all of this. They have a very clever way to make sure that nobody can cross-access data that is not relevant in their everyday life. So the people that are in the tax office, they don't see the health records, and the health people, the doctors and so forth, they cannot see the educational information that is in these different databases. And all of that is done very, very cleverly through what is now basically called blockchain technology. They actually installed this technology before Satoshi Nakamoto released the paper. They claim they basically were the first ones to start using blockchain in production before Satoshi actually came up with the idea. But that's a different discussion. So that's how it actually looks there. They have by now more than 1,500 services in production. So everyday life in Estonia is fully digital. You don't use ever any pen anymore to sign a contract. That's all been done by this digital identity card. They have ported that onto the mobile phones now. You can actually use a mobile phone with the SIM card holding your private key. And it started with tax. Tax also started in Switzerland around the same time, but then it stopped there, and here it started to develop in solutions like digital land registries, digital schooling. So everything in school is done on this platform as well. There's no physical certificates anymore. Then it goes on to the doctors' systems, where the doctors are actually issuing digital prescriptions. So you can actually get from the doctor, even if you just do a video call with him, you can get issued a prescription, go to the pharmacy with that, and ultimately get your medication without having ever been to a doctor directly. And so forth. So that's basically the story as we heard it in the video. That's kind of how this whole society developed. Now you also log into the banks in Estonia with your digital identity. You actually use the public transport system with digital identity. So everything that you do in your daily life is actually directly supported by this digital identity. And so I think that's the key why this success story actually took place there. And now let's look at, we heard already a few examples, let's look how this inspired other governments across the globe and what's actually happening now directly when it comes to this technology and how it's been applied with different initiatives. Now it starts, okay. So this is an overview of a few headlines from, I'd say, last 6 months when it comes to government interest in blockchain technology. Some governments have a national strategy now. They want to do nationally become thought leaders and become innovation leaders when it comes to this technology. We heard Dubai is very big in that. I'll come to that in a second. But also Malta, also places like Oman. I've been at a big week-long conference in Oman in November where they basically, the whole government pretty much was there and listening to what blockchain technology could actually bring to the country when they fully embrace this. Japan is probably the most progressed when it comes to supports of cryptocurrencies at the moment. They fully legalized Bitcoin, they fully legalized all their exchanges there. It's by definition now the most active when it comes to daily volumes of traded cryptocurrency. South Korea a little less, although they also started experimenting with private blockchain solutions in the country there, but they're a little more restrictive when it comes to cryptocurrencies now. Abu Dhabi as well, giving the neighboring state of Dubai, they also obviously had to do something about this, and they started doing a blockchain voting service with their exchange. And Georgia and Sweden, I'll come to that in a second, they basically, both countries are looking actively how they can digitalize their land registries. And then obviously The Economist last year wrote a nice story about this whole topic, how the governments will actually be probably big backers of blockchain technology going forward. Congratulations to the UK. The UK government was one of the first ones to recognize this, and they issued this report already in April 2016, how distributed ledger technology actually can enable the government here. They highlighted in this, it was 88 pages, I think, the report, all these use cases as opportunities for governments to embrace and basically improve efficiency of state services. So I guess, and I show this everywhere I go, this is a really good example of a government that is really open to start embracing such technologies and see what this actually could do to a country like the UK in this case. Okay, now we have the same issue. Okay, Dubai National Blockchain Strategy. Martin already said it. They have the most ambitious and the most aggressive stance when it comes to how this blockchain technology can support their country. They will want to be totally blockchain powered by 2020. It's a big goal. I personally think it's a lot of marketing behind this as well, because if you see where we are now, and that's where I would like to also be a little bit more realistic of what this technology can or cannot do at the moment, I think this is a rather aggressive goal. I think we heard from Patrick very nicely, we are at the very beginning. This technology is nowhere near scalable enough to even support such a claim or such an ambition. But they do it very well, and they have a lot of attention now globally. A lot of startups go there. I get every week about 2 invitations to go to accelerator programs or IBM incubator programs in Dubai. They're really, really aggressive about this. So that's the pro thing about it. In the long run, obviously, they will have a benefit from it. Now, the key use cases, I think, for blockchain technology at this moment in time, when it comes to governments looking into this, I think, as I said before, blockchain basically supports nicely what digital identity will do going forward. Online voting, we heard as well, this is a use case that if anything can do it, it's definitely the blockchain technology that can solve this big challenge. And lastly, digital registries of all kinds. Obviously, that's the foremost important use case of blockchain technology is timestamping and is basically therefore digital registries. I'll show you a few examples of each of those now. So blockchain digital identity, the ecosystem around that, we've seen this slide is also not so new anymore. It's probably also 6 months old or even older. But already then, there's a huge number of startups going into that space when it comes to blockchain and applications of blockchain. So all these startups, one way or another, apply technology like distributed ledger technology, private or public blockchain technology to the topic of digital identity. They start solving issues around privacy, how you actually can control your identity. A lot of those are actually doing KYC-related services. So for reusable ways of once you have it tested yourself or once you have been approved by a bank, that you can actually take that approval and that record and use it again with your mobile phone provider or a second bank or whatever, something that basically makes your life much easier when it comes to the KYC process. That's the most important use case when it comes to blockchain technology in the identity space. One example I would like to highlight, because also we're going to start working with them officially soon, is Sovereign by Evernym. This is a private solution of a digital identity solution, but a very good one. And I think this is going to be one of the contenders to really make a big impact on this side of the equation when it comes to digital identity. It's, as we heard before, not feasible to use any public blockchain at the moment to do this if you want to actually roll this out to a country like the UK. But Sovereign has solved a lot of the scalability issues. Since they are private, they obviously don't have that sort of consensus issues that like Bitcoin or Ethereum blockchains have. And so I think they are a very good one to watch if you're interested in the topic of identity. Nasdaq, now we come to the e-voting topic. Nasdaq has proven in Estonia again, already in 2015 I think, that e-voting can actually work in the context of shareholder voting, so delegation of shareholder votes in the proxy contest. They proved that there, and they basically had done that successfully. Okay. That's finished. I think time is up. Horizon State is a project in Australia. They just did a crowd sale with their project 2 months ago. They have done, in that context already, some unbinding votes in Australia with the platform, and they now try to produce a solution that can actually be used in political voting as well. So this is a very good example of where things are actually already live in a way or another. Okay. Now, a land registry. As I said, we have two cases that we would like to highlight. Here is Cromaway from Sweden, working with the government of Sweden to do experimenting with the Swedish land registry. They've done quite a good progress already over the last 2 years. I think they're at stage 2 now when it comes to the solution being rolled out and tested. There's an app, there's a good white paper on the topic and on the project themselves. The same thing is true for Georgia, if I get to that slide. With a different company called Fury. Can you go on with the slides? Good. That's a similar approach. They basically record all the Georgian land titles onto the blockchain now as well. Typically only the timestamping aspect of it. So you basically digitalize documents, take the hash and put that on a blockchain. But that's the first step, and that's the step that really works as well. Now quickly to my company, what we are doing. We basically deliver e-government as a service. So inspired by the Estonian model. Next slide, please. We would like to build services that the government enables the government to empower the citizens. So puts the citizen in the center by government trusted identity solutions and build services around that. And these services basically should be always built around the safeguarding and the self-sovereignty of the personal data that comes with such digital identity solutions. Next. Our technology building blocks are pretty simple. We use smartphones and only smartphones, so we don't use any tokens, any hardware tokens. The technology of smartphones has progressed so far by now that actually it's meaningful and it's secure. It's getting there for it to be used in its own way. We obviously back everything up with cryptography. We have pretty cool technology that we will apply to secure the application that we've built, so the app that we've built by enhancing it with behavioral authentication mechanisms. There's obviously key management challenges that we also face, like any other web app provider, but we're also working on that. And then in the bottom is this privacy engine that I'll come to in a second as well. So ultimately that makes everything self-sovereign going forward. Next, please. So at the moment, this product is all government trusted. So we believe, contrary to all the other identity providers, that is still needed that the government is backing up an identity. Or in the case of NGOs like the UN in Geneva we're working with, somebody that officially approves an identity once it's been opened. So basically the user of our app downloads the app, enters his personal data, and ultimately gets it approved by some official function to make it a government approved identity, and then can start using it. That's a very important aspect. With the identity, we give user access to a secure zone on his mobile phone to store important data that can be ultimately in the future digital driver's license or any other official documents that can be then used with this app in the context to prove yourself who you are. Yeah. Okay, so we build services around that. I'll just have a quickly look. And we started basically building also services for like access to buildings. Once you have an identity like this, you can enhance it by giving access to buildings, giving access to records that are coming through via our QR code solution. We see e-prescription already in production in Estonia. We also do that. So anything document-wise you can store on the phone as well. And ultimately the most biggest problem obviously we have is the e-voting. We want to enable with our digital identity solution ultimately an e-voting solution, because you ultimately have one aspect of the voting platform now covered with the digital identity on a smartphone like this, so we can basically start from there and start issuing voter tokens as we heard before. We have launched this as a project with one state in Switzerland called Schaffhausen in December. So we are live with this app. It's a mock-up there, but we have actually a live production system now in production there. So they use this now for the citizens of Schaffhausen. Once they are tested by the government, you have to go to their citizen office, and they basically check what you've entered into the phone to be correct, and then test you and basically enable you to use this identity. You can go with the phone and log into the citizen portal of Schaffhausen, so get government services through that portal by passwordless login. You can actually, on demand, provide your information to third parties if you want. So if you're online, an e-commerce shop wants to get you onboarded and you want to open up an account, instead of entering everything yourself, you just scan the code, upload your information, and you're fully in control, obviously, what you upload from your information, and so can actually make the onboarding process much more efficient. As I said before, we have a safety box for electronic documents. We also use it in the context of the casino there. So basically, if you want to go to the casino, instead of showing your identity card, you just scan yourself in. And lastly, we do the timestamping of the ID validation. So that's the context that connects to the blockchain now. We basically just do a timestamping solution with this. And that's obviously the first step to really make this then a self-sovereign project going forward. And with that, I come to the second challenge. That's our next deliverable. Our next big challenge is in 2019, we want to build an e-voting solution together with the University of Zurich. We've started the project addressing all these challenges that we heard before from Patrick. So that's, as we speak here, it's an ongoing project. To start with, we'll do an experiment this spring with student voting in Zurich at the university, and then hopefully from there take it forward to commercial aspects and then ultimately political voting. And last one, and that's concluding my presentation, if I get to that one. It's 2021, it's our vision, it's called Valid.global. It's taking what we have built now for a government and make that totally self-sovereign. So basically we want to take that identity solution and rip away the fact that you need to go to a government to get it tested and make it a self-sovereign solution. So you ultimately have similar app, and you're the first one to see. These are the first designs from our app that we just got yesterday, and the app that is basically then ultimately gonna something look like this. You have your identity, you have attached to that identity a lot of personal information, be it health information, be it financial information, be it geolocation information, anything that makes you you, and ultimately carry that with you. Then you can now, start in May this year with the GDPR regulation coming into place, request from any company that holds data from you to get an electronic copy of that data, and we then help facilitate loading that data up into your profile on the app. And then ultimately with that information, together with attestations that you get through your life, be it through Facebook, LinkedIn, or other social media means, be it through the bank that you open up an account that will attest for you that they checked your identity. With that basically a reputation that you build with your everyday life, you can then in a self-sovereign fashion ultimately start using this identity solution going forward. Valid will also enable you to monetize that data if you wish to do so. What happens at the moment, obviously everybody from Facebook to the doctors to anybody that holds data about you can monetize that. That's happening every day. And with our solution, we planned to actually turn this around and enable the people that use our platform to do that themselves and get paid for their data that's really just their data and should only be used and monetized in their context. So all of that is going to be this Project Valid, which we launched last fall, which we are actually in the middle of building up and releasing the first solution in this summer, basically the first mock-up of this whole idea of this app together with the data marketplace. And with that, I'm finished, and thank you very much for your attention.
Thank you, Daniel. Okay, we're going to bring a couple of extra chairs onto the stage now, and we're going to have Q&A time. So I'd like to welcome Patrick and Daniel back to the stage. Straight in there. So please do rustle up some questions. We'll come to you in a minute. So get your questions ready. Daniel, that was really interesting. Lots of lessons to be learned from Estonia there. Obviously, as you pointed out there, Estonia was a new country back in the 90s, really. So it could write a new history for itself from scratch. And you did give some examples of how the UK has looked at maybe using blockchain and in government contexts. But do you think it's going to be a lot harder for countries like the UK, not just from a bedded in amount of stuff we've got, systems we've got built up over the years, but also from an attitude point of view, maybe in government? Do you think those are hurdles for this kind of thing?
I mean, Estonia, yes, you were right. They were starting fresh, and so they had nothing when they started. So that's obviously helpful. There's no legacy systems. There's no legacy processes that stop them from doing it. But that's only one part of the equation. They also had a very, very, very open government when it comes to technology, and they embraced internet at the time immediately because they had nothing else that they should do, and so they could basically take the risk and fully embrace this technology of internet. And I think that's the same thing now again. Obviously, countries like the UK or where I come from, we have a lot of legacy. We have bureaucracy. We have hesitance and cultural, I would say, stubbornness when it comes to probably bureaucratic systems. But that doesn't stop somebody being really visionary in the government and say, okay, let's do this. And I think in the case of the UK, this Office of Science or whatever it's called, it's obviously doing that and advising the Prime Minister here to look into this topic. And I think they do. And I think the UK is also leading when it comes to your solution here for digital identity, if I'm not mistaken.
Yeah, I'd also like to add in. So the UK government are very welcoming of this as well. So one very good symbolism or example of that is David Cameron was at the opening, and I think he cut the ribbon for blockchain.info's new office. So, I mean, you have a prime minister open the office of a blockchain company. I mean, that doesn't really, that screams we're open to this.
Yeah. Okay. Interesting. I suppose with Brexit as that could be something that's a sticking point that means they're so distracted they can't deal with things like this, or it could be an open. After all that, it could be one of those kind of restarting things, and it might be an opportunity for this kind of thing. Patrick, when you were talking about blockchain-based voting, obviously that's a whole new world, and voting is fundamental to democracy. And as you pointed out there, it's really important that it's rock solid technically and very trustworthy. Do you think this is something that will be ever implemented on a national level anywhere in the world, or is it really more of an academic experiment at that scale?
I think the issue is that you need to convince people that this is going to work at a national scale. And over the past, I guess, 10 years, every single example has failed. So, I mean, you have that really classic Simpson episode where you have, I think, he's trying to vote for Bush or something to vote for the other candidate because the voting machine's just broken. So I think if you want any government to actually take this on, you need to prove that it works at a smaller scale. So it's just like scaling it up and proving that the technology works. Like even I think DEF CON this year was like a hacking conference. They had the voting village where basically a bunch of hackers went in and basically hack the machines within 24 hours. And the other issue is that a lot of people building these systems, they aren't security engineers. They're software engineers. And there's a critical difference there because a software engineer wants to get it to work. I mean, he's paid, he does the job quickly, then he gets out. A security engineer, like, we don't believe the world is honest. We try to break it. We believe everyone's out to get us. We're a bit paranoid that way. But they're the people you need if you want to build these systems.
Yeah.
Can I add something as well now? From a non-academic perspective, I think we're trying to over-engineer perfect solutions sometimes. And where I come from, again, can only talk about Switzerland. We have this paper solution now. We can basically post, and we obviously vote a lot. We have every quarter referendums and questions about new schools and whatever. I mean, so we have experience with voting, and so this system seems to be perfect, but it's actually not perfect as well. And so, trying to solve a problem where you can actually work around, probably by having algorithms comparing results for them to make sense or not. You can actually come up with a solution. I'm pretty sure that makes sense, not in the big scale at the beginning, of course, but in a smaller scale. And actually start trusting them. I think it's all about trying and also failing sometimes, and then learn from it and continue.
I think from a politician's point of view, nobody wants to be the politician that messes up democracy. Well, you know, I'm sure some of them do, but you don't want to be seen to be the one who messes up democracy. So, yeah, I suppose there's probably a lot of guts involved at a top level there, yeah. Does anyone have a question or anything they'd like to throw into the conversation? Oh, we've got lights on everyone. We can, I think we can get a mic to you if you. Yep, there we go.
You guys mentioned voting. You guys talked about the Estonia project. Their e-voting worked for them. He said that the people are using their mobile phones to vote. How come it's working for them and we can't seem to scale it here? Can't we just replicate what they're doing?
I can take a little stab at that. So, I mean, as you mentioned, there's trade-offs, isn't it? So the Estonia system is not end-to-end verifiable. You have no guarantee that your vote is included in the tally. And what's quite interesting is that people accept that. They say, okay, this is a workable system and it seems to be working okay. But it's actually difficult for people to independently verify it's working okay. So it's not fully transparent. I mean, if it was fully transparent, I could actually try to, show that it's broken. But I can't because it's not end-to-end verifiable. So sometimes it's even worth. I'll let you go ahead.
Yeah, I'm not an expert as well on the solution exactly how it works there, but again, it's obviously not the only one. People can also go to the ballot box as they do, and they actually do that a lot. I think it's only 27% or something that use the electronic way, and so you can obviously then compare the physical votes with the thing, so you can work around the fact that it's not end-to-end verifiable, which is, I think, at the end of the day, not. Again, in our case, if you send a letter and you vote via the postal mail to the thing, it can get lost in the postal mail, can be miscounted, it can be actually not dropped into the box in the end. Who can verify that? And that's, why should the technology be more stringently applied than a manual process? That's my question to these discussions usually.
No, yeah, the postal system's terrible. I can highly admit to that. No, I was also going to say, so on the Estonia system as well, that's sort of how they get around coercion resistance as well. The fact that it's not end-to-end verifiable. So the idea is that if I vote on my phone and I'm coerced, I should be able to go to the ballot box and recast my vote. And I trust the Estonian government to count my second vote and not my first vote. And because it's not end-to-end verifiable, the coercer can't verify that happened. So actually, sometimes there's some engineering trade-offs you can do. And that seems to be working so far.
Okay. Anyone else? Yes, Mike, coming to you.
Yeah, so my question is, if the problem is end-to-end verification, wouldn't it be logical to create a rather centralized ledger and then distribute tokens for every individual in the country that is eligible to vote? And then basically that would solve scalability, as with the problem with Ethereum. And at the same time, it's still a central system, but it would at least you would be able to, as you said, end-to-end verify your transaction.
So that's sort of you're sort of hinting on the consistency property. So the idea is that all the voting data is replicated across everyone in the election. So every single person has a copy of all the voting data. So then you can independently verify yourself that it's running correctly. But I think the issue is sort of when you're looking at a national scale election, you have this sort of trade-off where I want to be able to verify the election is running correctly, but I can't prove the other people how I voted. Because if I can prove to someone else how I voted, I can sell my vote. So blockchain doesn't solve that problem, but it solves that consistency property where everybody gets the exact same view of the election. So I mean, so then you're dependent on the voting protocol for the end verifiable bit. If you get what I mean. I don't, yeah.
I suppose one thing that you brought up, Daniel, was well briefly on one side was GDPR, and I've been looking into this a little bit over Christmas. It was like an idle thought that ended up on a chain of blog posts around the internet from various people talking about it, and how it relates to blockchains in particular. And yeah, so this applies to e-governance, but any kind of blockchain-based system. How GDPR's right to erasure sits with a permanent record. And there seems to be lots of disagreement about this out there. Any thoughts from either of you?
When I talk about blockchains and how it can be applied in this context of data, of personal data management, it's never going to be the case that we save the data in plain text on any blockchain. That's never going to be the case. So I think if you do a timestamping solution with a hash of a document or whatever file, digital file, that's, I don't know legally about how that looks like, if this is considered to be something that needs to be erased at demand, on demand, or, but that's a question I can't answer, but I think obviously that's going to be an issue if you want to have to fulfill that thing. But since what we are doing in our solution is basically we are fully decentralizing our product, so the user, the owner of the data is fully responsible himself what he does with it. If he stores it on a blockchain that is immutable, obviously he needs to be informed before he's doing that this is going to be the case, and so then obviously it's on his own responsibility to kind of sign that off, that fact.
Yeah, one thing that's been interesting around kind of stronger data protection in the UK is and in the EU is we've seen American companies, especially with face recognition technology, holding off on releasing things like Facebook. As you can't do face recognition on Facebook in the EU, but everywhere else in the world you can. There's lots of that kind of thing going on. There's an app that Google released in the States where it can recognize your face and it likens a piece of artwork to your face. And I just saw on Twitter today people are really annoyed with the UK version of the app, which doesn't include that feature. So I wonder if some of these blockchain-based systems might have geo-limited effects like here. There might be implications on this where the way things are deployed based on the fact that this system can't be applied in this part of the world because of the legislation there, or will everything be dragged down to the dragged up to the highest standard of privacy? Difficult question.
I guess the thing I would highlight is that going being on the face recognition. I remember seeing this video in China where you can order a burger, it scans your face, then it automatically deducts from your balance. So I mean that does exist out there. That is in China. I thought that was actually really cool. Also really creepy because that means they have a copy of my face. I think the issue with the benefit of a blockchain system is that you can't really stop it replicating. I mean, it's a bit like a virus. I mean, you join the network, you download it, you now have a copy. And it's really difficult to regulate around that because you have no control of the data. I mean, the minute you put the data into the blockchain, it replicates. And even if you don't do that, I mean, it's a peer-to-peer network. So the minute I create a transaction, I broadcast that to the network, it replicates across the network. So it doesn't even need to be in the blockchain for it to replicate. So for that reason, a lot of applications, like storing health records, for example, are a bit... That's why a blockchain may not always be suitable. I mean, it's suitable in terms of if it's within an organization and they're just trying to synchronize data within the organization, maybe there's some benefit there. But the minute you give it to the client and you let all these customers store this encrypted data, if those keys get lost, and as we're learning, key management's really difficult. I mean, 33% of Bitcoin exchanges have been hacked because they do poor key management. And I don't trust the government to do key management or any health care organization. So while it's encrypted, if those keys get lost, people have access to all your data. So in terms of global replication, it's quite scary.
Yeah, just very briefly, Daniel talked a bit about his work beyond his talk. Patrick, could you maybe tell us a bit about what you do beyond what you were talking about in the? Yeah, well, in your work, like how you ended up talking about what you were talking about today. Yeah.
Okay, so I guess when I started my PhD, it was back in 2013, and there's only like 5 academic papers on the area, so it was very, very new. But a lot of people warned me against it. They said that if Bitcoin died, so did my PhD, but I didn't really care because, I mean, I thought Bitcoin was really interesting. And I only did the PhD as an opportunity to get paid to do what I want and sort of investigate this area. But the reason I even got into it was because I spoke to my advisor about a PhD. And I had a meeting with him, and he was like, "Oh, Paddy, there's this thing called Bitcoin being used in Silk Road, like the dark markets. Do you want to look into it?" And I'm like, "Yeah, that sounds really cool." So that's sort of how I got into the area. And then throughout the couple of years, I mean, my research is really varied. So I looked at how botnets could use Bitcoin as a way where, so if you, for people who are not aware what a botnet is, it's sort of like there's thousands of infected machines out there, and you need some command and control center where you want to issue a command to the bots, then they can like DDoS a website. A Bitcoin-like system is an ideal command and control center because I submit the command to the network, the bots listen, they get it from Bitcoin, and they execute the command. And because of the censorship-resistant property of Bitcoin, that works really well. I mean, the fees are a bit high now, but that's a willing cost. And then after that, I broke one or two payment protocols being used in Bitcoin. And then after that, I sort of started doing the e-voting stuff. So I was more interested, okay, we have this blockchain. We now have these expressive smart contracts. Is there a way where we can combine cryptographic protocols like e-voting or auctions, etc., and can we use this blockchain in a meaningful way? And what we learn is that they both really complement each other really well. We have a system where you can't really keep any secrets. Then you have these cryptographic protocols where they're really good at keeping secrets, but it's really difficult for people to coordinate and store data and exchange data. So they just both fit really well together. And nowadays, I'm looking at how to scale these systems. So like stuff like Lightning. I don't know if you heard of Lightning Network, payment networks, state channels. So that's sort of my research now and how we can make that a bit more usable.
Hey, interesting. Any more questions? Yes.
Hello, thank you for your talk. They were both really good. I was wondering about the efficiency of Estonia and what would happen, or what you kind of think would happen if you were to scale something like that up in the UK. What would happen to our kind of management layer, our government? Would a lot of them be out of jobs? No.
So you mean scaling in the sense of the system, not the technology itself, no?
Both the system and the technology. My assumption is that if you introduce this kind of more efficient digital layer, then there will be a lot less work to do.
Well, that's true, and that's nothing to do with blockchain, but it's just generally the trend in digitalization strategies. And then I think in Dubai they claim they save, don't quote me, I think $1.5 billion a year in just paper handling from 2020 onwards, when they have a fully digital government there. So there's obviously efficiency gains to be made, and I think that should be a trigger for any government to start looking into this. But then I cannot comment on how scalable the solution in Estonia is to other countries. I know the company that's behind the system is called Guardtime. It's a private company that you can basically go to and purchase this backbone system from. So I guess they've built it so that it could scale up to potentially also a country like the UK, but I cannot really comment on that.
You can imagine civil servants sabotaging blockchain-based systems. We don't want to be out of a job. But I suppose everyone's talking about automation, aren't they, and how it'll take away jobs. But the counterpoint to that is we always find new things to do and new jobs to do.
Exactly.
So
I was also going to say there tend to be tedious jobs as well that nobody wants to do. Like really repetitive tasks that could easily be solved by a digital layer. If you want to.
Until we have AI that writes its own blockchain-based systems, and then we're all doomed.
And I'm out of a job.
Yes.
Thanks again, both really interesting talks. Linked to e-governance and also Estonia, I was wondering if you had any comment on the trajectory for government-issued digital currencies linked to all this stuff.
I remember having a chat with the Bank of England like last year, and they were I think they were sort of hesitant on it, but they had this idea where they could issue tokens. So they're like sort of, the source of new tokens. And then there'd be like a payment service provider layer where companies connect to that blockchain, then they offer services out to customers. So I know they had that sort of plan. I know Russia are looking at sort of cryptocurrencies or issuing like a ruble coin because they want to get around sanctions on a global scale. And there was something else I don't remember, but they are looking at it.
Venezuela just announced a coin to get rid of their issues with hyperinflation. Estonia, basically, Kaspar again announced, I think in September, that he wants to do an ICO for Estonia, so raising a cryptocurrency through an ICO for the country, which caused even Mario Draghi to comment. And he got a bit of a problem with that, but he got 200 million clicks on the article, I think. So they're also thinking about things like that. But obviously, given they are using the euro, they cannot really go themselves and do something like this. I think, generally speaking, in Europe, the idea is not to touch this for now, because it's just too risky.
Any other questions? Yep.
Did you ever think like of using a technology like the Sangle from IOTA? So maybe not like using a completely decentralized platform, but like distributed platform. So let's say every borough, let's say Hackney, has his own node running his node, and then everybody maybe has his own private key connected with biometrics, and the private key is stored in your phone, and nobody can change it, and then everybody can connect to the local node and provide their own vote, and then from there every node is like decentralized in a way using.
So that's sort of like the idea
Things.
behind a state channel. So if you consider like the blockchain, I described it as a global computer, but you can sort of describe it as well as an arbitration machine. It's sort of like a judge. So what we could do is that we could have 5 people, and we set up a channel where we can do this private computation amongst each other. So we could run an election without ever talking to Ethereum. We all put deposits on Ethereum, then we set up our own little private network, we run the election protocol, but if someone aborts, or if someone tries to cheat, then what you can do is you can send cryptographic evidence to the blockchain, then the blockchain's a bit like a judge, he rules his hammer and says, no, there's evidence of cheating, you lose your deposit. So in that case, we now get to a world where we can do this local computation, and that scales really well, but then we rely on this global root of trust to make sure that everyone well behaves. And if you misbehave, you lose your deposit or blah, blah, blah. So that's sort of, I think, what you're describing. You have one node, everyone connects to it, they run a protocol, but there's no guarantee they're going to be well behaved. And one way they make them well behaved is have some type of root of trust, where if they aren't well behaved, there's some form of punishment. I think that answered it.
Still based on Ethereum. You're talking like with.
Just any blockchain. Just as an abstract judge. I only think of Ethereum because that's what I'm working on at the moment. Yeah. But it could be any real expressive blockchain that could do that.
Yeah, I think maybe just for the problem of scalability, that's what I was thinking of IOTA. So every device can communicate with the other device. So it has to be confirmed by all the devices, and still we need to trust the borough, the central node.
They have that central coordinator, don't they? So there's still a bit of centralization there. But I mean, it depends what properties you're after as well. I mean, if you want... Centralization isn't a bad thing. If you there's a motto in the community called "Trust but Verify." I'm pretty sure it's like the Blockstream slogan as well, where centralization isn't a bad thing if you can verify everything they're doing. The reason why a lot of these systems don't scale is because it's more distributed in nature. There's like 20 nodes that are in charge of the network, or there's 1,000 nodes in charge of the network. If there's only one, it'll scale really well. But we just got to make sure this node can't cheat us. Like in the IOTA case, they have that central coordinator who sort of does that.
Yeah. Maybe let's see, EOS is gonna use like 20 nodes for every event, but nobody knows about it.
Well, we're going to have to finish the questions there, and we can continue all this chat during networking very, very shortly. Before that, we've got one last thing we need to do. But before we get on to that, I'd just like to please give a round of applause to our speakers, Patrick McCorry and Daniel Gasteiger. Okay, if you haven't put your business card in the nice vase that's being carried around the room there. You have your last chance now because you might win something. So get your cards out and drop them in. Okay. Drum roll.
Can I read it? Yeah. This is a Nick. Last name. Zdanov.
Nick.
Maybe you'll pronounce
Nick.
it better.
Nick Zdanov? Zdanov?
Yeah. I apologize.
And now it's for 50% off the Genesis conference next month.
Oh, all right. Alkesh Acharya.
Okay, I think we've done everything now, haven't we? Yeah? Brilliant. Okay, well, thank you very much. Here ends the formal part of proceedings, but please do stick around and have a chat and, and a drink. And so thanks a lot, and please give a round of applause to our speakers. Thank you.